just be y equals the square root of x. So that's the parent function of a square root. A reflection. So a reflection is going to happen when your a is negative. And what that would look like is y equals negative square root of x. So anytime you put a negative in front of that square root, it's going to flip it. And that's what we had right here. If I go back to Desmos, if I put a negative out in front of my square root, it's going to flip it over the x-axis. And that's going to be what that graph is representing right there. A stretch. Anytime your a value is greater than 1, that's going to stretch your graph out. Anytime your a value is between 0 and 1, that's going to shrink your graph. So anytime you have a number out in front of your square root that's greater than 1, that's going to stretch your graph. Anytime that it's between 0 and 1, that's going to shrink your graph. So heading to Desmos, if you take and you put a number in front, like let's say a 4, it's going to start to stretch it out. So it's going to start to make that square root function start to stretch and get higher quicker as time goes on. So that's going to be what we're looking at with a stretch. And then a compression, as you put a number between 0 and 1, it's going to start to flatten it out. And this should all be very reminiscent of what we talked about with other functions that we've been dealing with in the past. So that's also something we've talked about with our other functions. And then lastly, a translation. So a translation, your h is going to move you horizontal, and then your k is going to move you vertical. And what that's going to look like is y equals the square root. Inside your square root, you'll have x minus h. Outside your square root, you'll have your k. Now the h, you have to kind of think opposite. A minus h is a move to the right. A plus h is a move to the left. Plus k is a move up. Minus k is going to be a move down. So we also have a spot reserved for other radicals, so like cube roots, fourth roots, but we are only focusing on square roots. That's why I'm only filling out this column. So what are the graphs of y equals the square root of x plus 4 outside the parentheses? So first, if you look at your parent function, I'm going to draw in red here. Your parent function would be 0, 0, 1, 1. And then I'm just going to go 4, 2. Because my graph only goes up to 7, so I'm not going to do the 9. But all I'm using is the table from above that we put down in our notes. If I do a square root of x plus 4, that's going to shift my graph up 4. So each of these points is going to go up 4, and up 4. And then there would be my new graph produced, shifting it up 4. So we're going to start looking at those patterns as we did in the other functions, start to see how the h and the k start to move my graph around, move it up and down, so on and so forth. So that's going to be what we would see. Now a minus 4, you could probably think what's going to happen when I subtract 4? Well, that's going to shift each point in my graph down 4. And then there's going to be a picture for x square root of x minus 4. We just have a graph being shifted down 4. And that's basically what our notes will continue to take a look at. We've got this will be a shift to the right. This one will be a shift to the left. We'll have some other transformations thrown in there. But all in all, for our square root graphs, we can start to see those same types of patterns that happen that we've seen in other functions. If you're still having trouble with the patterns, I would suggest that you head into Desmos. So like this square root of x, I just did plus 4, put a plus 4 there. Gotta turn it on, and then you can start to see where those functions are moving. So if you're still having trouble with the minus h moves you to the right, the plus h moves you to the left, put it into Desmos so you can check it out, see which way it's going, and start to further develop those patterns. Heading to Delta Math really quick, just want to show you kind of what you'll be practicing. So we're on practice 6-8. There's only one assignment, so we only do one day. We will do a discovery method. And I apologize, it's kind of hard to see, but you'll see your parent function right here, and then you'll see a red dashed line, and you need to fill in the h and the k, and if it's a flip, you can do a positive or a negative to get your parent function to match up with the red dashed function. So for example, if I'm looking at this one, it looks like it's starting at 0, 0. It goes 2 to the right, and then it goes 1 down, but it's still got the same orientation. So it's not a flip, but it goes 2 to the right, 1 down. Now, if it goes 2 to the right, that would be x minus h. And here in Delta Math, they put everything as plus. So to move to the right, though, remember moving, it's kind of opposite. Moving to the right is x minus, so that's 2 to the right. We're putting a negative 2 there. And then moving down 1, the h is opposite, but the k is regular. That would just be a minus 1. Once you click out of the box, you'll start to see that graph shift. So if you looked away for a second, it started at 0, 0, and now it shifted to the right 2, down 1. It's now matched up exactly with that function. So now we have x minus 2 minus 1. So you can kind of see how they've changed the function now as we added in those numbers. We got it correct. It tells us. We submit our answer. Now we're ready for the next one. So we're looking at using discovery to kind of play around with the h and the k. They'll go through it again and kind of get more familiar, get a little bit stronger with how those h and k values work. And then also if it's a reflection, you can use the negative a to get it to reflect. So those problems will look like that. Your second set of problems, you will see the transformation of functions. You will use a multiple choice. So you're going to pick out which one is going to be representing moving from the parent function to that red dashed line. And I know it's kind of hard to see from my screen, but when you get into Delta Math, you'll be able to check that out. Well, that brings us to 10:03. We went a couple minutes over, but just wanted to give you a heads up on everything that's expected. So you have those 10 problems to practice. If you haven't watched the video, you can go beyond where we went in the notes, kind of check out some other problems. And then don't forget about in your schedule, if you click on that green Desmos, it'll bring you right to Desmos, and you can kind of play around with that, use that as well. But I'm going to leave it at that. If you have any other questions, you can stick around. But if you're ready to go, break off to work on your own. You guys have a great day, and we'll see you tomorrow for reviewing the quiz. Thanks for joining.